I'm looking at this set of linear equations, and it is 3x plus 2y is equal to 17. 2x minus 5y is equal to 5. Okay? If I add, I'm going to get 5x minus 3y is equal to 22. None of my variables got eliminated. Okay? So let me erase that. If I subtract, I'm going to get 1x plus 7y is equal to 12. Again, none of my variable got eliminated. Right. So here's what I'm going to have to do. I'm going to have to change the look of either one or both of these equations. What I have in mind is I would like to eliminate the x variables. Okay? What that means is we need the coefficient, the number in front of the x variable, to be the same. So what I want to do is find the lowest common multiple of these two coefficients. And the least common multiples between 3 and 2 is 6. So what I'm going to do is I'm going to take the top equation and I'm going to multiply by 2. That means that every single term is going to need to be multiplied by 2. So the top equation will now become 6x plus 4y is equal to 54. I'm going to take the bottom equation and multiply it by 3. The second equation will now become 6x minus 15y is equal to 15. You'll notice now I have the leading coefficient in front of x to be the same number. So now what I can do is I can subtract from top to bottom. So 6x minus 6x, the x now has been eliminated. All right. When I took 4y minus a negative 15y, I'm going to get 19y. When I took 54 minus 15, I'm going to get... Have you caught the mistake that I made yet? Here's the mistake that I made. It's right here. 54 should not be there. 2 times 17 is not 54. 2 times 17 is actually 34. So let me fix that mistake really quickly. All right. So 34 take away 15, that would be 19. And if I divide both sides by 19, I'm going to get y is equal to 1. Okay. So if I was to graph this, it's going to intersect at y equals to 1. I need to figure out what the x coordinate is. So what I'm going to do is I'm going to choose an equation that I would like to use. I'm going to choose the very first equation, the 3x plus 2y is equal to 17. And I'm going to substitute in y equals to 1. So I'm going to get 3x plus 2 times 1 is equal to 17. And I'm going to solve for x. So I'm going to subtract 2 from both sides and get 3x is equal to 15. And divide both sides by 3. I'm going to get x is equal to 5. So the intersection point between these two equations is going to be at 5, 1. Let me do one more example. All right. Suppose I have negative 7y plus 2x is equal to 3 and 5x minus 4y is equal to negative 6. I want you to look at these two equations. We cannot use the elimination method as of yet. The reason is because we need the x to line up with each other and the y to line up with each other. Okay, so this is an easy fix. Let me rewrite the top equation. Let me rewrite it as 2x minus 7y is equal to 3. And I'm going to leave the second equation the way that it is written. 5x minus 4y is equal to negative 6. All right. So now you can decide, do you want to eliminate x first or do you want to eliminate y first? There is really no right or wrong answer for that one. If you're going to eliminate x first, you would probably multiply the numerator by 5, the top equation by 5, and the bottom equation by 2. I am actually going to eliminate the y first, just so that you can see that there isn't really a right or wrong answer. I'm going to take the top equation and I'm going to multiply it by 4. So what that means is every term is going to be multiplied by 4. I'm going to take the bottom equation and multiply it by 7. So what that means is every single term is going to be multiplied by 7. So my numerator is going to become 8x minus 28y equals to 12. My second equation is going to become 35x minus 28y is equal to negative 42. All right. Next thing I'm going to do is I'm going to subtract the top equation from the bottom equation. So vertically, 8x minus 35x is negative 27x. I have a negative 28y minus a negative 28y. These two negative will make it positive, so therefore the y is now eliminated. I'm going to rewrite my equal sign. On the other side, I'm going to get 12 minus a negative 42, so that would be 54. Right? I'm now going to divide both sides by negative 27 and get x is equal to negative 2. Please don't stop yet because you do need to go back and find the y coordinate of the intersection point. So I'm going to use the first equation, negative 7y plus 2 times negative 2 equals to 3. So I'm going to solve for y. I'm going to add 4 to both sides. So that will give me negative 7y is equal to 7. Dividing both sides by negative 7, y is then equal to negative 1. So the intersection point between these two linear equations is at negative 2, comma, negative 1.